this video, we are going to learn how to find the particular integral using operator method. So we have considered the linear non-homogeneous differential equation with constant coefficient, where this a0, a1, an minus 1 and an represent the constants. In the first step, we will write its operator form. So operator form means derivative with respect to x, that is represented by d. So this is the nth derivative of y, so we can write d raised to power n into y. This is n minus 1 derivative of y, so we can write d raised to power n minus 1, so on. After that, we will collect the coefficient of y, and whatever the coefficient we have, that is in terms of d, and we call it as function of d. So that is represented as capital F of d. Now the particular integral is evaluated by using this form. So in this video, we are going to learn the case when this Rx is of the form sine or cos, that is sine ax or cos ax, or maybe sine ax plus b or cos ax plus b. So in this case, the particular integral is evaluated as we will replace d square by minus a square, and the right hand side Rx function is as it is. Now what is a A? A is basically a coefficient of x. So in this case, the coefficient of x is a. Same for this, we just need the coefficient of x, not a constant term. So we will replace the d square by minus a square, provided this denominator term is not is equal to 0. In case this denominator term is 0, in that case we will call it as it is a case of failure. So case of failure when f of minus a square is equal to 0. In that case, the particular solution is written as, instead of f, we will take its derivative, first order derivative with respect to d, Rx function as it is, and the additional term is x. Then we will substitute d square by minus a square. It means if the denominator term in the previous case getting a 0, take its first order derivative, put d square by minus a square, and take additional term as x. In case first order derivative at minus a square is also is equal to 0, then particular solution is written as x square into, rather than function, we will take its second order derivative because the first order derivative is 0 at minus a square, and d square is replaced by minus a square, and the right hand side function Rx is as it is. Let's understand this concept with the help of example. In this case, first we will write its operator form. It is a second order derivative, so we will write d square y plus 4y is equal to sine x plus 3. Now take coefficient of y, that is a d square plus 4 into y is equal to sine x plus 3. For particular solution, ypx is equal to 1 upon d square plus 4 into sine x plus 3. Now what is the coefficient of x? So coefficient of x in this case is 1. A in this case is 1. So now what is the a square? That is again 1. Now in this case, d square is replaced by minus a square. So finally we will substitute d square as minus 1. So we have 1 upon minus 1 plus 4 sine x plus 3. So that is equal to 1 upon 3 sine x plus 3. And that is the final answer in this case. Let's answer the next question. So again we will write the operator form. Its operator form is d square y plus y is equal to cos of x plus 5. Now take the coefficient of y. So coefficient of y is equal to d square, and in this case coefficient of y is 1 is equal to cos of x plus 5. For particular solution, for particular integral ypx is equal to 1 upon d square plus 1 cos of x plus 5. Now in this case the coefficient of x is, that is 1, so that is the value of a square is again 1, minus a square is minus 1, so we will put d square as minus 1. So substitute here, so we have minus 1 plus 1 cos of x plus 5. So this is a case of failure as the denominator term is getting 0. So in this case, we have the solution as ypx is equal to, so rather than fd, we will take its derivative. So fd is equal to d square plus 1. So its first order derivative is with respect to d, that is the 2d. So put its derivative rather than fd. So that is 1 upon 2d, right hand side function as it is. But there is an additional term, that is the x, because we are taking a first order derivative in this case. Now we have learned in this case d square is replaced by minus a square. But now we have d. So how to tackle this case? So there is a two way to answer this question. First case, multiply by d and divide by d. In this case, so we have x by 2 d upon d square cos of x plus 5. Do not take this x by 2 over here because that is the separate term as compared to this one. So this 1 by 2d is operated on the cos x plus 5, not on the additional term. Now this is equal to x by 2. So d square value in this case is minus 1. So we can write d upon minus 1 cos of x plus 5. So this is equal to minus x by 2. D stands for the derivative with respect to x. So what is the derivative of this term with respect to x? That is the minus sine x plus 5. So final answer in this case is x by 2 sine x plus 5. This is a one way to answer this question whenever we have 1 by d form. And the second form is d stands for the derivative with respect to x. If I take 1 by d, that is the antiderivative, and antiderivative get converted into the integration with respect to x. So from here we can write x 1 by 2 as it is, and 1 by d get converted into the integration of cos x plus 5 dx. So this is equal to x by 2 integration of cos is sine x plus 5, and that is the final answer. So you can check that in both the cases we are getting the same answer. Either you can follow this step or this one. Only in the case whenever we have 1 by d form. Let's answer the next question. So in this case, the operator form is already given to you. We can directly write the particular integral ypx is equal to 1 upon d square minus 5d plus 6 sine of 2x. So now what is the coefficient of x in this case? That is the 2. So that is the value of a is equal to 2. So a square is 4 and minus a square is equal to minus 4. So we have sine form. So we will replace d square with minus a square. Means d square is replaced by minus 4. So substitute d square by minus 4 in this case. So we have 1 upon minus 4 minus 5d plus 6 sine of 2x. So this is equal to 1 upon minus 4 plus 6 is 2 minus 5d sine of 2x. So whenever we have this type of a form, there is a denominator term that contains derivative d. Additional term, some constant is there. In that case, how to proceed further? So we will form a minus b into a plus b factor, so that we can write it as a square minus b square. So in this case, it is a 2 minus 5d. We multiply this quantity with 2 plus 5d as well as divide with the same quantity. So we can write 2 minus 5d into 2 plus 5d divided by 2 plus 5d sine of 2x. So from here we have, this is 2 plus 5d, put it in a bracket form, divided by, so this is a 2 square minus 5d square. So again put it in a bracket form because it is a whole 5d square sine 2x. So this is equal to 2 plus 5d divided by 4 minus 25 d square into sine of 2x. 2 plus 5d divided by 4 minus 25. Now d square value is minus 4 sine of 2x. This is equal to 2 plus 5d divided by 4 plus 100, that is 104 sine of 2x. Now this is a numerator term. So this is like x plus y into something. So we will multiply x with something and y with this something. So we have 2 into sine x by 104 plus 5 by 104 d sine of 2x. So now we need to remove this d, and d stands for the derivative. So in this case the answer is 2 by 104 sine x plus 5 by 104. So derivative of sine 2x is, that is the cos 2x into 2, and that is the final answer in this case. So in this case, the particular integral has started from here. So we will take this factor in a denominator into right hand side function cos 3x. Now what is the coefficient of x in this case? That is the 3. So in this case, the value of a is 3. A square is 9. So minus a square is minus 9. So we will replace d square by minus 9. So substitute d square by minus 9. So we have 1 upon minus 9 plus 2d plus 10 cos of 3x. So this is equal to 1 upon 2d minus 9 plus 10, that is a plus 1 cos of 3x. So again we need to create a minus b into a plus b form. So it is already a plus b form, so we need a minus b. So what we will do, in this case we will write it as 2d plus 1, multiply this operator with 2d minus 1 upon 2d minus 1 into that rx. So this is equal to 2d minus 1 upon, so 2d square, that is 2d whole square, minus 1 square cos of 3x. So this is equal to 2d minus 1 divided by, that is the 4d square minus 1 cos of 3x. So this implies 2d minus 1 upon 4. D square value is minus 9 minus 1 cos of 3x. So this implies 2d minus 1 upon. So minus 36 minus 1 is minus 37 cos of 3x. So this implies we will multiply the numerator term with the right hand side function cos 3x. So we have 2 times of d into cos of 3x minus cos of 3x divided by minus 37. So finally ypx is equal to, so d stands for the derivative. What is the derivative of cos 3x? So derivative of cos 3x, that is equal to minus sine 3x into 3. So we have 2 times of minus 3 sine 3x minus cos of 3x divided by minus 37. So we can take negative sign common from the numerator and that will cancel out with the negative sign in the denominator. So finally we have 6 times of sine 3x plus cos of 3x divided by 37, and that is the final particular integral in this case.